right, and I pray that they're good test questions and not Philadelphia lawyer questions. Hopefully they won't be. Let's look at the first one. And everybody see my screen? Yes or no?
Yes, sir.
Okay, one person sees it. That's good. 1.576/25. 1.576/25. First of all, is it a good test question / standardized test question? For the function, find the points on the graph at which the tangent line is horizontal. Ooh, we get to find what? We get to find where the vertex is. That's what we need. Now, that's to the third power. You know it looks like what? What does the third power look like? Look at your family of graphs, and that's not a rhetorical question. I'm asking y'all to interact with me. What does a cubic function look like?
It's like a binomial, except it goes up, down, then back up again. Or
okay, from left to right, it's increasing.
Yeah.
Like that. Yes or no?
Yeah.
Okay, this one has a greater than 1/3. So let's look at it again. Our function f of x is equal to 4/3 x cubed minus 3x plus 2. This is greater than 1, so we know it's being compressed along the x-axis and stretched along the y-axis. So we know, I'll do this in green, instead of being like this, it's going to be more like this. And we know that the y-intercept is 2. And we don't know what the x-intercept is because we haven't done complete and square or anything like that. So I would say it's looking something like this. Now there's going to be a point in here somewhere where there could be or not a horizontal line. And it's going to be very hard to get a horizontal line on this function. But let's go ahead and type it in the calculator because we need to look at it. So I'm going to take my handy dandy calculator and we're going to type in y is equal to 4/3 x squared. I'm going to put that in parentheses. Second insert, and that's just me. Okay, I must have hit something. Okay, let me just hit clear. All right, let me try this again. Parentheses, 4/3, close parentheses, x cubed minus 3x plus 2. And graph. Let me turn the stat plot off. Hit zoom standard or zoom fit. I think zoom 6. There we go. And we are lucky it does have the saddle in it. So we need that vertex right there and that vertex right there. So hit second, trace, and we want the min and the max. And the max is on the left. Left, enter, right, enter, and that just slows down the mathematical process for the calculator. And there's one vertex. Write that vertex down. That vertex is going to be negative negative 0.8666026, and y is equal to 3.7320508. So that's one vertex. The second vertex is the mean, so that's going to be second. I can't find it. Calculate mean, left, right, and guess. Okay, 0.866. (0255) and y is equal to 0.2679492. Okay, and that's where you type in the points at where the tangent is horizontal. And it says use a comma to separate. Type using radicals. You don't need radicals, just right here. And I don't know if they want just the x or the y's. I'm just going to type in 3. And there is your answers right there. I believe if you do the calculator, you're going to get those same numbers. There's your negative, and there's your positive. Now, what are they doing? Well, I'm going to show you a trick, and it's called f of x then f prime of x, f double prime of x, and so on. F fifth prime of x. Now, I really don't care about these because these you really don't need, okay? But this is the actual function. The first derivative is the acceleration, and third velocity. Second is velocity, second is acceleration. Or in some cases, this is the function. This first derivative, you could actually say it's your increasing and decreasing. And this one is your inflection points. So the first and the second derivative will give you different things in different applications. In math and science, it gives you the velocity and the acceleration. In non-math and science, on a curve, it gives you the increasing and decreasing values as well as the inflection points on the graph, wherever it turns. So there may be some application, I don't know if it's 1.7 or 1.8, it's the one that says more derivatives. Is that 1.8? Somebody look on your outline, I believe it is. And I think they're gearing you up in this problem for that. Because actually, you can set this question up, and you can take the first derivative and the second derivative, and that would give you the inflection points as well as, and I'll go ahead and show you. Can you see my paper now? Or did I just not have it up? Y, nobody's going to say anything? Okay. 4/3 x to the third minus 3x plus 2. Y prime is equal to 3 times 4/3 x to the 3 minus 1 minus that 1 right here will come out front. And that 0, this is x to the 0, that 0 comes out front. And of course, that last one goes out because it's a constant, and that's just what happens. That goes out as far as the derivative. So your first derivative, y is equal to, that cancels, 4x squared minus, well, this is going to be minus 3. X to the 0 is 1. 1 times 3 is 3. So that's your first derivative. Your second derivative would be 2 times 4x to the 2 minus 1 minus 3x to the 0. That 0 comes out front and cancels the whole thing out. So y double prime is equal to 8x, and that's to the first power. So that's your second derivative. And this is your first derivative. Now, you could actually look at y 4x squared minus 3, and you could actually find, set it equal to 0. Let me set it equal to 0 on the next page. Hold on just a second. Y prime is equal to 4x squared minus 3. Now I'm going to set the first derivative equal to 0. Okay? So I'm going to set this first derivative up to equal 0. And 3 on this side would be 3 is equal to 4. Excuse me, 4x squared divided by 4. 3/4 is equal to x squared. X is equal to the square root of 3 over 2. Now that's also the positive and negative. Okay, positive and negative square root of 3 over 2. So you have a positive and a negative. And if you look at the number line, this is negative infinity, this is positive infinity, and you have 0 here. Well, negative 3, 3, square root of 3 is 1.7, which is almost 2 over 2, which is almost negative 1. So I'm going to put right here, I'm going to put negative square root of 3 over 2 right there. And up here, I'm going to put positive 3 square root of 2 right here. And of course, past that is 1. That's a negative 1 and a positive 1. Now, this is a point, and this is a point, and I want to check and see what happens when we plug in negative 1 to our function. All right, if you plug in negative 1 into this function here, what are you going to get? Well, -1 raised to the second power, that's going to be a +1. And 4 minus 3 is what? A positive number. So positive means that the function is doing what? It's increasing on -1 side. That's supposed to be green, but that green shows up just like dark. So now pick 0. What is happening with 0? Well, 0 minus 3 is what? Negative. So negative and then what's happening with the +1? 1, 4 times 1 is 4. 4 minus 3 is what? 1 positive, so that's positive. So this is what happens. If you draw this, you've got increasing values. Let's draw a number line up here. You've got increasing values until you get to the square root of 3 over 2, and then the square root of 3 over 2 comes down, and then this point starts to what? Go back up. So you know you got some kind of graph that goes up to this point at square root of 3 over 2, and then at this point it starts to go back up at positive square root of 3 over 2. And that's what's happening with this function. It's increasing, decreasing, and increasing. So that's where this is heading. This is for your information. These two right here are for your information, but that's where this is heading. So let's see what the question asks. Yeah, that's all it asks. Excuse me, I don't know why I'm yawning today. Excuse me. I wonder if they do the derivative. Let's see what they do. If they do the first and second derivative. I don't think they do. Find the first derivative. We did that. And that's going to be 3 times, that's going to be 4x squared minus 11. See what they got. 4x squared minus 11. Well, they're not going to get it. There it is, 4x squared minus 11. Then they set it equal to 0. That's what I did. And you get that number right there. There's the positive and the negative, just like I said. I don't know what they're doing there. It looks like they're plugging and chugging. Oh, the square root of 11, yeah, that's what they're doing there. They're plugging in. I'm just looking to see. Yeah.
Hubert, I do not like this question for the test.
Yeah, it is a little bit too deep.
It is.
I would rather you find the first and second derivative, but if you take the first derivative of that, what they're doing is they're taking the first derivative and they're setting it equal to 0. And that's what I did right there. So first derivative, set it equal to 0 and solve it. Let's go to the next one. I'd rather spend more time on questions that pertain to the test. So you sent me another one. That's 76. That goes down here. We'll do that one. That's 7, 11, 11, 15, 1.715/12. Okay, this can be a test question. Now, I would use the quotient rule. And I think you have to use the quotient rule. Now, you could use the power rule. And let me just show you that right quick, because you could use both. I don't know which one's more difficult, but I'm going to use the quotient rule to do this one. F of x is equal to 3x to the fourth over 5 minus 2x to the third. And over here, f of x is equal to 3x to the fourth over 5 minus 2x to the third. And let me show you the whiteboard. And on this side, I'm going to do the quotient rule. And on this side, we're going to change it and do the product rule. So the first thing I'm going to do here is I'm going to do f of x is equal to 3x to the fourth times 5 minus 2x to the third power. Negative. All right, and now you do the power rule. I meant the product rule here. First times the derivative of the second plus the second times the derivative of the first. Now over here, I'm just going to go ahead and do the quotient rule. Denominator, f prime of x is equal to denominator times numerator prime minus the numerator times the denominator prime. I'm just going to write it 5 minus 2x to the second power prime divided by denominator squared. Okay, now on this side, that's going to be f prime of x is equal to 5 minus 2x to the second power times 12x to the third power minus parentheses 3x to the fourth. And this right here is going to be the chain rule, and that's going to be times 2 5 minus, well, that's going to be negative, well, 5 minus 2x, and then 2 minus 1 is 1, and then what is the derivative of negative 2x? Divided by 5 minus 2x to the what power? So the derivative 2 comes out, 5 minus 2x, 2 minus 1, and then the derivative of 5 minus 2x is negative 2. Now, I'm just going to try to clean this up a little bit. 12x cubed times 5 minus 2x to the third power. This is not going to clean this. Let's see, that'd be 2, negative 4. That's going to be a negative 12. And we distribute that negative. So that's going to be positive 12 to the fourth. And I'll check my algebra. times 5 minus 2x to the first. All that over 5 minus 2x quantity what? Squared. Now y'all check me, make sure I didn't make a mistake.
Hubert, you never make mistakes.
Yeah, right. I do make mistakes. That's the problem. All right, but make sure I didn't make mistakes on this one. All right, now let's see what we get over here. First, times the derivative of the second, which is going to be negative 3, 5 minus 2x, and that's going to be negative squared. Let's see, no, that's going to be negative 4 times the negative what? 2x, or negative 2, plus the second, 5 minus 2x quantity squared, times the derivative of the first, and the derivative of the first is 12x to the what? Let's see, it'd be 4 times, yeah, I'm checking to make sure. So let's check it again. First times the derivative of the second plus the second times the derivative of the first. We're going to be able to take this negative 2 and this negative 3. That's a positive 6 times 3 is 18. So that's going to be 18 x to the fourth. I'm checking. Negative 2 times negative 3 is 6. 6 times 3 is 18 x to the fourth times 5 minus 2x to the negative fourth plus 12x to the third times 5 minus 2x quantity squared. Well, this one's going to be a little bit different because that's going to come down. The 12, there's the 12x cubed. And I think that's going to probably, that's probably going to simplify. I'm going to go with the quotient rule. And I don't know how far they want to go with this. You could actually distribute that here. This would be a total mess. Or you could, yeah, you could do this. I'm going to go to the next page. I'm going to rewrite everything. 12x to the third times 5 minus 2x to the third plus 12 to the fourth. Is that 12 to the fourth correct? I don't look correct. $12x to the fourth times 5 minus 2x to the first over, well, that's a common denominator, 5 minus 2x squared and 5 minus 2x squared. And this cancels and makes that a 1. So that'd be 12x to the third times 5 minus 2x. This would cancel and leave one of these, but take that one out, plus 12x to the fourth over 5 minus 2x to the first power. So I don't know if they want you to keep going. We could keep going here. I don't see us getting anything that cancels. So let's see. I don't know what they got. Let's see what they got. I'm just going to hit 3 and let's see if we're going toward the right answer. They use the quotient rule. Six x to the third. Okay, I'm starting to see x to the third. Ooh, I'm not seeing it. Negative x plus 10. I don't know about that. I see that could be reduced. I really don't know what we did. Did I make a mistake somewhere? Let's see what they did. See if they did the quotient rule. Yep, they did the quotient rule. I'm just looking. I'm looking. I'm going to go down and see where they actually plugged everything in. They're doing the quotient rule, so I know I've either made a mistake or I haven't gone far enough. Anybody got a clue where I went wrong? Let me keep going with the product rule. Let's see what we get with the product rule. 18x to the fourth over 5 minus 2x to the fourth plus 12x to the third over 5 minus 2x to the fourth. Well, this is simple. I can multiply this by 5 minus 2x to the second over 5 minus 2x to the second. And that's going to give me 18x to the fourth.
Hubert, for the top, I got 60x to the third minus 6x to the fourth.
I'm sorry, for the what?
For the top of the fraction. The bottom I got the same, but the top I got 60x to the third minus 6x to the fourth.
Are you talking about doing the quotient rule?
Yeah, that's what I did.
Okay, show me where you got 60. Did I miss something? Oh, right here. You distributed right here.
Yeah.
I haven't done that yet. Or did I? Did I do that yet? No, I haven't done that yet. You talking about right here?
Yes, sir.
Okay, I'm gonna do that in just a minute. Okay, I'm gonna try to do that. I'm gonna see what the product rule gives us. That's what I'm doing right now. So that's going to give us plus 12x to the third times 5 minus 2x squared over 5 minus 2x to the fourth. And of course, that's going to give me 18x to the fourth plus 12x to the third times 5 minus 2x squared over 5 minus 2x raised to the fourth power. Okay, there's my 5 minus 2x to the fourth power. And what's 18? Well, I got 18 plus 2, 12. So that may be, hold on a second. Okay, I bet you $1 to a donut hole. They did, hold on just a second. 18x to the fourth plus 12x to the third, 25 minus, well, let's see, that's going to be 2 times negative 2, so that's negative 20x plus 4x squared over to the fourth power. 18x to the fourth plus, gosh, I don't know what's 12 times 25. 10 times 25 is 250 plus 24 is 274. Somebody help me out there. 274.
Yeah, 300.
I'm sorry, what?
300.
300. 300. Yeah, 12 quarters is $3. Duh. X to the third minus 240 x to the fourth. Y'all check me out there. Plus 48 x to the fifth. I'm looking. That'd be x to the fifth. No, that's not going to work. I don't think that's going to work worth a flip. But I'll go ahead and keep going. 18x to the fourth minus 240x to the fourth. That doesn't look right. And that x to the third and that x to the fifth. I think we got a problem there. But we do have 5 minus 22x to the fourth. So let's look and go back to the quotient rule and see if I finish it out, what am I going to get? So here's the quotient rule, and that's going to give me 60x to the third minus 24x to the fourth plus 12x to the fourth over 5 minus 2x to the first. And to get a common denominator, I'm going to have to multiply these two by 5 minus 2x. I don't know. It's a far stretch. There's the x to the third, but this right here is not going to work. I've got an error somewhere, y'all. I'm going to do it one more time with the quotient rule, make sure. Sometimes you have to do them 2 or 3 times. You don't get them the first time. Y is equal to 3x to the fourth over 5 minus 2x to the third. And I have no idea what y'all are thinking because y'all don't talk. So only 1 or 2 people talk. So I have no idea what the class is saying. All right, so that's going to be denominator times numerator prime minus the numerator times the denominator prime over the denominator squared. Okay, we'll try this again. First times the derivative of the second, so that's going to, I'm sorry, denominator times numerator prime, so that's going to be 12x to the third. So 12x to the third times 5 minus 2x to the third minus brackets 3x to the fourth times 5 minus 2x to the first multiplied by negative 2. All that over this raised to the fourth power, or let's see, to the sixth power. Now this right here, really can't do anything with that right yet. This right here we can do something with. So that's going to be 12x cubed times 5 minus 2x to the third minus brackets. That -2 times that +2 is a -4. -4 times 3 is -12. 12x to the fourth. I'm going to put -12x to the fourth times 5 minus 2x to the first, all over denominator to the sixth. And that is to the third power. So that's going to give me 12x to the third times 5 minus 2x to the third plus 12x to the fourth times 5 minus 2x. All that over 5 minus 2x to the sixth. Well, I could cancel the 6 and the 3. Okay. 12x, that'll leave. No, I don't want to do that. Good gracious. That right there is a mess. This is not a mess because that's 12 times 60. And 2 times 12 is 24. I'm not seeing that. And plus that, let me pull this back up. Anybody see a mistake I might have made? I don't see anywhere. I need to cancel something out because that 5 minus 2x to the third power, that's a mess. And that would be that to the third power. 12x cubed times 5 minus 2x to the third power over 5 minus 2x to the sixth power plus 12x to the fourth 5 minus 2x to the first power over 5 minus 2x to the sixth power. And that's going to knock that out and make that a third. So that'd be 12x to the third over 5 minus 2x to the third plus that goes out there and marks this out to be the fifth power. So that's going to be 5 minus 2x to the fifth power and 12x to the fourth up here. I'm not seeing it. I'm not seeing what they're seeing. And I've either done something crazy wrong or I'm not going far enough with the algebra. So I will have to work on that one a little bit for y'all. Unless somebody can say something and interact with me and see if I've made a mistake or I haven't went far enough. Anybody?
Well, the first portion of your equation's right on the top, just not the second part, I don't think.
Well, you talking about the bottom part?
No, that's like second half of the top part.
12x. Okay, I'll check it over. Let me check it. First, our denominator times numerator prime. We'll find it. Let's go back and look at it. Okay, denominator times numerator prime minus the numerator times denominator prime. And that's a 3, right? Is that a 3? Yeah, that's a 3. I'm making sure I wrote everything down right. Okay. 12x to the third, 5 minus 2x cubed, 3x to the fourth, 3, I see it.
Yeah, and then it's
Thought that was a
times
2.
the -2.
I wish somebody had said something. Okay, then that'd be a -2 right there. That's a 3. So that would be 3 times 3 is 9. And 9 times 2 is what? 18?
Yeah.
Okay. 18. I'm looking to see anything else. Well, that would be, since that's a 3, that would be to the second power, right?
Yeah.
Let me make sure. So that would be, instead of 3 minus 1 is 2. So that would be to the second power. And that would be to the third power here. Let's see. 6, that'd be to the fourth power here. But I don't know if I want to do that. Well, that will take this one out, and that will leave 12x cubed. That would take that out, plus 18x to the fourth, and that would take that 6 and that 2, that would go out, that would be to the fourth, and this would be to the third, and this would be 18x to the fourth. Correct?
Yes, sir.
And this would be to the fourth. Was still, that doesn't help us out very much. Now, we could multiply this by 5 minus 2x, and that would give us 12x cubed times 5 minus 2x plus 18x to the fourth, all over 5 minus 2x to the fourth. And then 18 times, or 12 times 5, what is 12 times 5? 60? 60x to the third minus 24x to the fourth plus 18x to the fourth, all over 5 minus 2x to the fourth. And what's negative 24 plus 18? 6?
Yes, sir, and that's the right answer right there.
We got it. We're on the right track now. 60x
It's
to the
60.
third.
Yeah, minus 6x to the fourth, and then over 5
6x
minus
to the
2x.
fourth, over 5 minus 2x to the fourth. Now, see, there's a prime example, and you can factor out an x to the third, a 6x to the third right here. That's a prime example of what happens when you do an error. You have to go back and what? You have to go back and find it. And that's negative, that'd be what? 10 minus x over 5 minus 2x to the fourth. I'm not going to sit here and tell you that I can do calculus right off the top of my head and come out with the, exact answer every single time. You can't. All right. And what do you do? Well, just like real life, when you get knocked down, you get back up and keep trying. So that's a prime example. Let's do another one. Is that, I don't think, if I did put a test question on there like that, I would make sure you had plenty of time and not give you 15 of them. Might give you one, but that one I had to do 2-3 times. Okay, hopefully that helps. I hope I didn't confuse you. Let's do another one. Oops, sorry. Let's go back to 130, and we just did that one. That was for 2 of y'all. Or was that 15? Let's go to 19. All right, this is the product rule. 4x minus 1 to the 4th power. 4x minus 1 to the 4th power. 1 minus x to the 5th to the 2nd power. All right, let's go ahead and start on it. First, I like to use my colors. I'm going to start using my colors again. Times the derivative of the second. Plus the second. Times the derivative of the first. And I'm going to do the derivative in pink. And that first one is going to be 2 times 1 minus x to the 5th to the 1st power multiplied by 5x to the 4th. Be a negative 5x to the 4th, wouldn't it? Yeah, because 0, that's 0, minus 5x to the 4th is negative 5x to the 4th. And then plus 1 minus x to the 5th squared. And this is going to be 4 times 4x minus 1 to the 3rd power times 4. Okay, so got all this, and that negative 5x to the 4th and that 2 will be negative 10x to the 4th. So y prime is equal to negative 10x to the 4th. And what's 4 plus 1? No, that's not the same. Sorry. That's going to be 4x minus 1 to the 4th. And 1 minus x to the 5th. Plus 1 minus x to the 5th squared times 16 times 4x minus 1 to the 3rd. Yuck. Y prime is equal to negative 10x to the 4th times 4x minus 1 to the 4th times 1 minus x to the 5th plus 16 times 4x minus 1 to the 3rd times 1 minus x to the 5th squared. Well, there's a lot of algebra there to do. And I don't really think they want you to do that much algebra. If they do, well, we'll just have to go to another page. Okay, they did use some algebra. There's the 1 minus 5, or 1 minus x to the 5th, 4x minus 1 to the 3rd. I'm looking to see what they did. Yuck. This is some raunchy algebra here, because you've got x to the 5th at 28. Lord have mercy. 1 minus x to the 5th and 1 minus x to the 5th. It looks like to me they just went through and did the algebra. Wow. That 4x minus 1 to the 4th power, that'd be the same thing as 4x minus 1 squared times 4x minus 1 squared. And that 4x minus 1 to the 3rd power, I can't believe they did all that algebra. I'm going to look and see if they actually did all that algebra.
Yeah, they make that problem like 5 steps.
From where we're at right now, 5 more steps?
Well, I mean, it's pretty long to get the final answer. You have to do a lot of algebra for sure.
Yeah, and I just don't see that. Here's where factor out the common factors, yeah. Okay, we could factor out, okay, I see, maybe we could factor out. Let me write this on the next page and I'll try to factor out what I can. All right, we've got y prime is equal to 4x minus 1 to the 4th power times 1 minus x to the 5th plus 16. Wait a minute, I didn't write down the right thing. Y prime is equal to negative 10 x to the 4th, 4x minus 1 to the 4th, 1 minus x to the 5th, plus 16, 4x minus 1 to the 3rd, 1 minus x to the 5th squared. All right. Well, the only thing we can factor out with the 16 and the 10 is a negative 2. So y prime is equal to negative 2. And what can we factor out here? 4x to the 3rd. 4x minus 1 to the 3rd power. And 1 minus x to the 5th to the 1st power. So we're going to factor that out. And that's going to leave us with 5x to the 4th and 4x minus 1. The 1 minus x to the 5th cancels out. plus -2, that's going to be a -8, so that's going to be -8 times the 4x minus 3's cancel, and leaves you with 1 minus x to the 5th to the first power. And that's going to give us y. This is going to stay the same, -2, 4x minus 1 to the 3rd times 1 minus x to the 5th. Here, we're going to distribute this, I hope, and that'll give us 20x to the 5th minus 5x to the 4th. That's going to be -8 plus 8x to the 5th. And that's going to be y prime is equal to -2, 4x minus 1 to the 3rd power, 1 minus x to the 5th, 20x to the 5th, plus 8x to the 5th is 28x to the 5th, minus 5x to the 4th, minus 8. And what did they get? $28 to the 5th for 5x and plus 8. They factored out, okay, they factored out a 2. I factored out a -2. So that's the difference. That would have made this a positive and made this a -5x to the 4th. So that's why it came out like that. Did everybody understand why I got different signs? Because I factored out a -2. Yes, no.
Yes, sir.
Okay, I'm gonna ask Miss Hollister because the rest of the class is not communicating with me. All right, y'all mad at me for some reason. I don't know what I did, but
I'm
what
mad
I
at
do to make y'all mad at me. Okay. Y'all ain't never been this quiet before. What'd I do? Miss Odom, what'd I do to you? And nothing. All right, let's go to the next problem.
Hubert, you got anything planned for this weekend?
No, not really. Just same old, same old.
Nah.
Not really anything. When you're a teacher and you don't have anything to do, I'm gonna be on the farm mostly. 1.735/16. No, I'm gonna go to Las Vegas for the weekend.
Yeah, I'll come with.
All right, this one says y is equal to u to the 47th power, and u is equal to 5x to the 3rd minus 3x squared. Well, I don't know exactly what they want you to do, but I can tell you one thing. I'm going to plug that in for u, and it'd be all that trash to the 47th power. And that's what I would do. This one says dy du. Well, that would be 47u to the 48 to the 46. And then du dx, well, that would be 15x squared minus 6x. And then find dy du. So there's several different ways you could do this problem. One is you could take the derivative of y, you could say y prime is equal to 47 u to the 46th, and u prime is equal to 15x squared minus 6x. And then you can plug that into that. Another thing you could do is you could take the u to the 47th, y is equal to u to the 47th, and plug in 5x cubed minus 3x squared. So that would be 47, y prime would be 47, 5x to the third minus 3x squared to the 46th power times 15x squared minus 6x. Now, that's one way to do it, or you could take the 15x squared minus 6x and plug it into this, but then you would have to do the chain rule again. So I don't know exactly what they're wanting us to do on this one. I would go with the substitution. So let's look and see. Okay, they're doing it separately, like I did right here. They're doing it separately. And this one is going to be 15x squared minus 6x. 15x squared, shift up. 15x squared minus 6x. dy dx would mean that I'm going to plug that in to this and actually get this right here. But I'm just going to hit 3. And that should be what I got right here. Okay, so this right here is du or dy du, or it's y prime, 47u to the 46. And then this is du dx, which is equal to 15x squared. And then here is dy dx. All right, 3 or 4 good problems. I'm going to have to redo that first problem. So somebody tell me which problem that was. I'm going to redo that first one. Which one was it? Anybody know? Or did I figure it out or what? I can't remember. Oh, here's another one.
We ended up figuring it out.
Okay. Here's 1.5 2076/25. Okay, we did that one, didn't we? Yeah, we did that one. Okay, we did that one. Let's check this 1.8. This is probably first and second derivative. Let's see what it says. Yeah. Find the fourth derivative. Dadgum. I ain't never found the fourth derivative before. Y is equal to 2x to the 5th. Y is equal to 2x to the 5th. Actually, this is a good test question from 1.8 because it's short and what?
Simple.
Sweet.
Short and sweet, yes.
Never mind.
Yeah, that's all right. You're a failure, Mr. Melnick. That's what it is. You're a failure. That's okay, Mr. Melnick. We're used to it. 5 times 2 is 10, x to the 4th. Y double prime, 40, x to the 3rd. Y triple prime, 120x, 120x to the 2nd, and y to the 4th. What is it? 240x. That's a good test question for 1.8. And I can tell you right now, I'm not going to give you two or three questions out of 1.8. Because finding the first and second derivative, you're not going to have one like this. Hold on. You're not going to have one like this to find the fourth derivative. Okay? You're not going to have one like this to find the fourth derivative. You're going to be asked one like this for a fourth derivative. Because now what I could do is I could give you one question on the test, this question right here, and tell you to find the fourth derivative. Would you rather do that, or would you rather just me do a little bit out of each section?
I think a little bit out of each section.
Yeah, you don't want to do this to the fourth derivative.
No.
You'd be writing, you'd have about 10 pages of work. Appreciate y'all's interaction. Thank you very much, class. Thank you for your interaction. All right. I appreciate those that do interact. The rest of y'all suck. All right. Any questions? All right. So I'm not going to type in those. I'm just going to type in 3. And y'all can check them. Oh, they just went straight to the, okay, they went straight to the fourth. Well, they had to do all of them. They ain't Rain Man. All right. So that's now again, I'm going to write this down for y'all because technically y'all can do 1.8 homework now. 1.1, 1.2, 1.3, 1.4, 1.5, 1.6, 1.7, 1.8. 20%, 10%, and 70%. That's what it's going to look like on your test. So if I give you 20 questions, or 4, let's do 10, which I'm going to give you probably 20, but 4 questions. If I give you 10 questions, 2 is going to come from here, 1 is going to come from here, and 7 is going to come from there. Double it, 4, 14, and 2. So you're probably talking about first, second derivative, or one like I just did, find the fourth derivative, and that's going to be it for 1.8. Okay. Now, how does it look? Well, you know we're having what you call it, spring break. We're not having class Thursday. So that means that y'all have all week and all break to do 1.1 through 1.8 homework. I'm going to expect more questions Tuesday when y'all come back. What happens if you don't send questions? What does that mean?
You think we got it all?
And what am I going to do then?
Make us take the test.
I'm going to show you the test, and I'm going to assign the test. So it's up to you.
I think the test is already assigned on our homework, if I'm not mistaken.
Is it already assigned? The test is not.
Oh, it's just a review test?
I haven't assigned the test, have I?
I haven't seen it.
Let me look.
Oh, Lord. My labs.
No, it says Hubert's review test. So I'm guessing that it's just,
Wait a minute. Let me go look right quick, because I don't remember assignments. Lord, no, that was y'all's first test. That was Unit 1 test. Yeah.
okay, yeah.
Yeah, this will be called Unit 2, Chapter 1. And it'll cover all these sections right here. Okay.
Gotcha, yeah.
All right, let me shut down this and shut down the recording.